I think we will start with a short introduction from you for yourself, because not everybody watched the panel beforehand, so not everybody knows you. Can you give a short introduction to yourself,
Sure.
please?
I actually give an introduction in a talk as well, so
Okay.
it might be a duplicate. I saw
Yeah,
that
then.
you're not supposed to, but then I didn't find it later, and I did enter it in it anyway. Yeah, so I've been a professional programmer for over 30 years. Among my accomplishments, lots of open source code, worked founded Codename One, lots of stuff at Sun Microsystems, original WAS toolkit and stuff like that. A couple of books, that sort of thing. Lots of time being a consultant. As I said, worked at Sun Microsystems and Oracle Aton for quite a bit. Lots of conferences, that sort of stuff. Usual for old guys. You know,
Okay.
it's
Great.
mostly that.
Okay, thank you. Then I would say we start with the pre-recorded run. As mentioned before, you can always ask questions in the chat and the QA. Enjoy the talk, and we see each other later again.
So who loves being on call? It's one of those painful duties we need to carry out in a global economy. I sleep around 5 hours per night, under normal conditions. And still, being on call is no picnic. It's stressful, even if we resolve the problem. So let's talk about minimizing that pain and literally extending our life thanks to the reduced stress. So, in case you haven't heard of me before, I was a consultant for over a decade. I worked at Sun Microsystems, founded a couple of companies, wrote a couple of books, wrote a lot of open source code, and currently work as a developer advocate for Lightrun. My email and Twitter accounts are listed here, so feel free to write to me. Please follow me on Twitter because it's a completely new account and I have an embarrassing number of followers, so would appreciate that. So Tom Granot is the guy that actually created and submitted this talk. I'm essentially filling in his shoes. So most of the stuff here was created by him. I just adapted it to fit my style. So after we do on-call for a while, we get into the habit of looking at every problem as a fresh problem. When a problem reaches us in this situation, it's usually a vetted problem that we actually need to solve. An engineer didn't solve it before or solved it and didn't document it. Real life isn't really pretty and things explode and collapse in ways you did not expect. The DevOps on call knows how to fix things created by DevOps. Configuration problems, servers running amok, and other fun system stuff. Support engineers on call know how to fix application problems to some degree, as explained to them by the original developers and as the documentation states. The problem is that the environment we're at in real life is complex. We have changes going in all the time, support queries, networking issues, hardware failures, and coworkers messaging us. Sometimes being on call feels like an action movie mechanic trying to fix a plane mid-air while being shot at. For any problem that relates to anything remotely complex with the application logic, an on-call developer is called. Since money is of issue, the service must operate at insane SLAs. Business guys come up with insane ways to charge more money all the time, and our teams push new code out of the door all the time. Keeping up with the pace is just hectic. And nobody logs all the right things all the time. So things get messy and are even harder to keep track of. Let's take a quick step back and talk a bit about observability. Now, I'm going to commit the cardinal sin of speakers by reading out the content of the slide. But this is important, so bear with me. Observability can be defined as the ability to understand how your systems work on the inside without shipping new code. That last part, without shipping new code, that's key. Monitoring systems do just that. They monitor your infrastructure and tell you what's going on. Observability is about much more than that. It's about the level of insight into our running system that will save us from the need to redeploy. In a properly observable system, we can tell what's wrong with the system just by asking it. It used to be that I would take my car to the shop and tell the mechanic about a weird noise I heard. Now I take my car to the mechanic, who connects the car computer, and it tells him everything he needs to know. My car is observable. And if you think about it, it's an amazing on-premise installation with a complex service contract. That's pretty impressive. We need to aspire to that level of serviceability for anyone using our observable application. With our current app, our tools tell us some pretty amazing things already. We live in a golden age of observability. Back when I started, we used to walk up to the machine and kick it to observe the sound of a failing hard drive. Now we have so many tools we can rely on when we're on call. We need to start asking questions and then choose the appropriate tools that can answer those questions. How do you understand what is happening when inside the application? You read the timestamped logs to get an event log of sort of your application. If the app is sluggish or unresponsive, we have the IT metrics, which indicate CPU, RAM, etc. Again, useful stuff. We can monitor application-specific stuff with service metrics. The name changes from company to company, but these are things that are business adjacent. Actions that are specific to your application and how the app shows up for the user. For instance, how many failures of transactions, how many transactions overall, etc. When I say transaction, I mean billing transactions and things like that that are application specific. I don't mean database transactions and low-level stuff like that. That's a different thing. This is more business-oriented for your specific needs. How do you check long tasks inside the application? How long they take to complete and how responsive the application is. You instrument and take a look at traces that show you, well, for lack of a better word, traces of your application that tell how long things take to perform. There are many such tools that can inspect things like endpoints that can surgically go inside and give us information about that endpoint. How do you check how the application itself feels? You can use a profiler to see how the memory looks, what's taking up resources, what's taking up CPU, etc. And this gives you a deep sense of where time is spent. There's obviously more complexity to that, especially with throughput and problems of that sort. but profilers are a crucial tool that not enough people use. How do you go down a random application code path step by step in development time? Well, that's easy. You use a debugger to explore how the logic of that specific application actually looks like on the inside. You actually use the debugger in the development environment to try to reproduce the problem and step over it. That's a pretty crucial part in solving these sort of problems. And finally, exception monitoring. How do you know when an error is thrown and catch it before you actually walk over the logs? You need a tool that catches these things, synthesizes them to you, and alerts you about these sort of errors, which are usually bugs or problems that you need to address before you actually get notified by the user himself. So this is also a very important part of your observability and things that tools should tell you today. So, but let's take a step back for a second and assume you have a chaos game day at work. These are events that are designed to simulate various failures in your system. And if you don't have that, well, the first tip is have a chaos game day. You need that, and you need every observability tool that we're talking about here, because you need the ability to look into your system. So that's definitely a good place to start and play with those things. And here's an example. In order to see how your stack and application holds up, if they potentially happen, if there's a potential problem in real life. When running such an event, there's usually a preordained individual dubbed the Master of Disaster. And that person, his sole job is to make your life a living hell. Sort of like a dungeon master in Dungeons and Dragons, who runs you through scenarios that are sometimes far-fetched, but are good practice for that on-call muscle that we need to strengthen. And that Master of Disaster, if he's really smart, he can be really cruel. And that's an important thing, both in a dungeon master and in this case, because he'll know the specific problems that your observable systems won't detect. And he can simulate those problems for you as part of this gameplay and essentially send you to a loop within your code to look for a problem and help you with practicing for the worst possible problems. So when you reach an actual on-call situation, this won't be as painful as it would be during the practice. We usually say it's hard during practice, it's much easier when battle comes forward. That's actually a military saying. So if we were to enumerate all the possible failures, we will never be finished. There's too many small edge cases and unforeseen circumstances. But we could try and categorize many of them into a set of issues that are rather difficult to test, monitor, and or plan for. And when they happen, they tend to leave havoc in their path. This might explain why we can't figure out what's going on in 5 minutes during on-call. Why, despite having so much tooling in place that supposedly should increase traceability, we're still having a hard time explaining what's going on. How do you check for incorrect application state? resulting from a programming error? How do you know that someone wrote a feature that behaves incorrectly under some set conditions? This is practically impossible to detect using traditional monitoring, and it's safe to assume the tests didn't catch it as well since the logic is somehow flawed. The DevOps people and the support engineers will have a hard time figuring out why the service is behaving in that way without jumping into the source code, which they obviously shouldn't do. That's your job. So how do you ask questions about code level quantitative data? Basically anything that has to do with understanding the size of objects in runtime, how long a specific piece of code inside a method, or basically anything that has to do with quantitative data in runtime. You have to instrument metrics originally. You can't do it in runtime. Unless you have a metric there already, it would be impossible to know that you're facing an imminent out-of-memory error because that specific data structure is literally exploding in size. You can't tell that unless you instrumented that in advance. How do you check for swallowed exceptions in runtime? You can prevent checking in code that has an empty catch block, but inevitably some will pass through the cracks. The nature of these exceptions is that they get swallowed. A specific action will fail despite the log showing that it worked correctly. These are especially tricky where the logs for the rest of the process are not great. It's difficult to follow through a specific process and understand exactly what failed there. How do you plan for what happens in the interactions of multiple components in real time? When two pieces of software supposedly conforming to a strict API end up not playing nicely due to circumstances outside of your control, such as API changes, networking timeouts, unexpected formats, etc. How do you understand unexpected code paths due to real-time behavior, circuit breakers tripping, users coming in with unexpected request parameters or state? How do you ask systems more questions about these user-specific issues? This was recently demonstrated at GitHub when a user incorrectly logged into a different user account. So this and pretty much all of these are very common problems in the real world for which we have relatively limited observable capability. How do you ensure the result of a specific execution is always the same, regardless of race conditions? Static analysis can get you part of the way, but flaky tests that end up getting ignored are sometimes races hiding in plain sight. How do you deal with the real effect of parts of your code working in parallel, serving multiple customers on any given time, and how one service affects the other? Not all architectures can or should be designed around microservices. And if you're running a monolith, one part can impact the other part in ways you couldn't initially expect. And in fact, in many microservices, there's obviously the ideal microservice, and there's the reality of microservices, which is pretty far apart. So there's quite a bit of problems related to cascading effect in microservices as well in the real world, and not in the whiteboard drawing of microservices we often see. So the problem is we can't predict all possible outcomes, especially as our systems scale and the components we build need to exist and interact with each other and need to exist or interact concurrently. This is a pretty complex problem, and tools just don't give us all the insight that we need in these situations. So we have enough background. Let's jump into our company and look at a simulated problem we have for an on-call. Let's talk about your company's on-call. I'm saying your company, even though I'm talking about an abstract concept. Not our company, not your company, sort of your company as in all of our companies. Pretty much every company we go to has the same basic on-call setup behind the scenes. So when you say your company, it's really our company or any company. We're all 24/7 companies nowadays. Unless you manage the local corner shop, you have customers practically everywhere. We're all more or less the same in terms of our on-call work. There are obvious differences, but the core concepts are the same. Pretty much all major companies are tech companies by now. We all need to have a developer on call at all times. Having fast response to disaster can mean millions not lost in revenue. Actually, slow response would mean millions lost in revenue. That's probably the more positive or negative way to phrase it. We also need a developer, DevOps person, and possibly a couple of support engineers to serve as the first line of defense when responding to customers. There's also the Network Operations Center team that's in charge of monitoring the systems. I won't get too much into all of those roles and focus mostly on the developer role, since that's the one I'm most familiar with. So, a problem appears. A certain subset of players in the system are reporting that purchases are not going through. They're trying to buy our product and the purchase does not go through for some reason. Items aren't credited to them. Support engineers don't see anything problematic in the specific user account and defer to ops. The DevOps guy looks at metrics which show nothing. The logs show nothing. DevOps aren't really sure what's going on. The service is obviously malfunctioning, and now it's time to wake up the support engineer. So this is the stack for our sample company. But it could be the stack for your company. It's pretty standard and common all around. This is a microservices-based application. We have services for credit card processing, transactions, fraud, inventory, billing, and gateway. The DevOps engineers set up a monitoring stack for each one of those production services. So a credit service box would contain its own monitoring service and would run in its own container. All production services are containerized, replicated for each type of purchase to distribute the load. The monitoring stack details container health. This is a common practice for microservices and not a bad idea overall. Whether that's the right decision isn't relevant at this point, as we're talking about on-call. At this point, it's pointless to debate architectural decisions. They were already made. We sometimes need to support problematic architectural choices. That's just life. This company just installed Datadog and are currently in the process of migrating the on-prem monitoring stack over to APM. It's not quite done yet, so they're not relying on it now. And that's not something that's actually discussed here, but I think it would be very familiar for most of us. Yeah, there's additional services coming in, and things are halfway through, like in pretty much every company I've ever worked for. So this adds a dimension of realism to this specific demo. By the way, this monitoring stack is based on a GitHub repository from Stephen Porden. I hope I didn't butcher his name. You can see the link at the bottom of the slide. And the reason we took it from there is to keep this as authentic as possible. This could be your stack. It could literally be a copy and paste of your stack that's identical. So before we proceed, let's look at the project a bit. As I said, it's a microservice-based project with several moving parts. We're using IntelliJ IDEA here for the project and Maven to build it. This is a standard Spring Boot JHipster project. If you're familiar with that, it's pretty standard stuff. You can see on the left side, all the microservices we discussed in the architecture slide. Now, let's move on to the demo part. We have an on-call in progress. The user experiencing the problem already went through support and DevOps, and they even got us the user ID, which is 24,085, 24085. That would come in handy soon enough. So the first step on any on-call developer does is open the logging system and try to find the problem in the log. Since we have the user ID, this becomes very easy. We can just type in 24085, 24,085 into the filter, and then we can see the logs that are applicable to us. There are a few logs, not too many. They all look pretty decent, everything finished as expected. There are no exceptions or errors to be seen. This is pretty bad. This literally gives us nothing. And unfortunately, this is all too common when dealing with production issues. Now, the right thing to do here is to file an issue right after this task is complete, with a request to open more logs. Another option would be to change the log level and try to reproduce the issue. But right now, that isn't practical in the short term. So before we activate the user and try to dig further, we're going to dig into the source code and try to find the issue. The log provided some names of source files that are applicable. I'll go over them in the backwards direction, which is a habit I picked up. Failures usually happen towards the end. So it's often more convenient to go back to front rather than front to back when going over logs, and sort of work our way backwards. So let's go over the files from the log entry one by one and try to guess where the failure occurred. Looking over the inventory resource, it doesn't seem to be problematic. It has the right logs I saw in the code and nothing special there. I can start digging deep into the validate transaction method, but I'd rather check the other entry point first. Transaction resource is the next class, and it's even simpler than inventory resource. The same is true for credit resource. But fraud resource is more interesting. At first look, the class looks normal and good, but when we dig down, the problem seems pretty obvious. There is an auto-generated catch statement that some IDEs generate with no logging by default. The developer somehow left that in place, and review somehow failed to pick it up. Sadly, these things happen. This points us right into the area of the code we need to investigate. But we got lucky. Notice that we have a lot of logs here, but most of them are completely useless. We need a better way to track source level issues of this type. So this was a pretty simple app with a trivial bug, yet it's a tedious runaround to fix that trivial bug in that trivial app. In production, the situation is worse. Our apps are far more complex, and with multiple engineers pushing huge changes. Bugs that are much harder to spot than this are bound to make it into production. So there must be some way to account for all of these things that our tools don't tell us. How can we make sure that when we do an on-call, we don't need to dive through the code and go bug hunting at random locations? That is obviously an untenable situation, especially for larger systems. I think the best long-term solution is continuous observability. This is a rising field where we can effectively ask the installed servers a question and get an instant response. This field has many facades, but the one I work in is in many ways a reinvention of what we think of as a debugger for the cloud. There's lots of areas within this field, and the ability to get insight into your server in runtime with things that you couldn't know during development is super helpful exactly in these situations. Because we should have obviously added logs, and we might have added them if we had better support for source code testing and linters and things like that. But that's just one problem. It's, to quote Rumsfeld, the known knowns and the unknown knowns. Obviously, it's hard and impossible to know the things that we don't know in advance. And these sort of tools let us inject information at runtime to be able to ask questions in runtime like a debugger is able to do when we debug locally. And that's super useful. So as I said, Lightrun is my employer here, and they provide essentially a debugger for your production. You should check it out, and sorry for the plug, but I'm contractually obligated to my startup overlords, and it really is a cool product. We also use it to debug the production servers in my other job at Codename One. You should check out that article on my blog too. So let's summarize the strategies we need in order to win at on-call. The first thing I think that's probably most important is to know and love your on-call. It's a cliche, and I know, but everyone has on-call. It's a fact of life. It's not going away anytime soon, and there's no reason to fight it. If you built something that's now running in production, you need to own it. And if you won't make it better, no one else will. I do support every day and do it a lot. People are sometimes surprised I have the patience for all the cases I field every day. I get asked a lot how I'm able to keep my cool and give support to people who sometimes don't appreciate it. For me, it's a mix of many things like yoga and family that keep me grounded and humble. But ultimately, I love supporting other developers, and developers are my people. And when they succeed, I feel part of their success. If you can't feel that, then on-call might not be for you, or you seriously need a vacation, possibly both. So I suggest taking your ego and putting it in a box and putting it aside. It should be there. It's okay to have an ego, but being able to relax it and flex it like a muscle, and also let it go like a muscle, is an important ability for on-call, because you need patience and you need zen for that. Get your tools ready. That's the second big tip, and you need tools that answer the questions and that people often have. What type of things do you have in your disposal or inside your context that DevOps and supporting engineers don't have already? Are you better oriented on the latest changes in the application logic? Are you subscribed to the GitHub updates, and do you get all of them? Do you read everything? Because sometimes reading from that fire hose can be impossible. Do you have code level visibility they don't have? Bring your own tools as much as possible. And in here, I want to talk a bit about linters and things like that. You should be prepared. The problem we saw earlier might have been solved just with a good linter configuration. So if you don't have that in your commit pipeline, it should be there. So definitely spend time doing that and integrating a proper pipeline in advance, and be prepared for those cases, but that will obviously only save you from these trivial problems. Documentation is key. Prepare documents, also known as runbooks, with common things to check and how to check them. If you think something that happened might happen again, prepare a document with what you did for the next on-call. Don't think it'll happen again. Document anyway, because it probably will. The analogy I usually give my team is about dog poop. A friend once asked me why I pick up my dog's poop when no one's looking, and the spot is sandy, so it's unlikely anyone will step there. I explained that dogs always take you to the same spot to poop. If I don't pick it up, I will probably be the guy who steps in it later on. The same thing is true with documentation. I often run into the same cases over and over. It happened to me more than once that I Googled a question and spent a while reading a very familiar answer, only to discover that I wrote the answer. Now, I'm old and senile, but no one can keep up with the amount of information we need to process every single day, especially with the stuff your teammates are running into. So document everything, write it down in a searchable system. This is crucial. A system that has decent search capabilities. Can't stress this enough. Have a list of tools and terminal commands you can run fast to get visibility that is granular to the specific problems you solved. When Tom was an SRE, he had a bash RC that had various levels of abstractions for it that he would load before an on-call session. Specific Docker shortcuts, JQ shenanigans, and other things that provide instant visibility into the running application. I have many shell scripts that instantly send me into the machines and let me remotely tunnel into the database so I can quickly verify any issue I need. Anything you can automate beforehand becomes far more important when dealing with a P1 issue. I used to work at a company that built flight simulators, and we had around 15 fighter pilots who worked for the company, including the CEO. Every time we did something big, we had a huge debrief meeting where everything was discussed, not with the goal of casting blame, but rather with the goal of strengthening what worked and fixing what didn't. This is a core fighter pilot best practice that I took with me to every job since. The problem was solved just isn't good enough. We need to look at our successes and see how we can improve on them. Did we waste time looking in the wrong place? Did we miscommunicate with a customer? Could we have better phrased the question to the customer? These are the type of questions that we need to raise in a post-mortem, and we need those all the time. We need post-mortems for practically every issue, every week. This is an important lesson that you should carry on with you. Because people usually limit these things only to failures, and that's a huge mistake, and it does lead to failures. You should always do them, even with successes. And you should be your own biggest critic when it comes to these sort of meetings. I can't stress this enough. This is a hugely important ability. Know what you can know. Know what questions you don't actually need to know how to answer. Sometimes an ops issue gets all the way up to the developer by mistake. Ask questions and be part of the team. I can't stress enough how many times I went to companies as a consultant only to discover that the two guys sitting literally side by side didn't bother to talk to each other. As a consultant, I made a lot of money just by talking to people that I didn't know and opening communication channels within the company, a company that I literally didn't work for. This is something sometimes hard in a work environment where you need to actually start discussing things and you think, oh, it's obvious to that guy, it's obvious. Check, always talk. The guy literally sitting next to you could be the solution to the problem you're looking at right now. Tell people what you're working on, look at what other people are working on, and ask questions. Having a daily meeting is obviously a big contributor to that, but it's often not enough, and sometimes people are too silent in those meetings. You need to speak up, and more importantly, you need to listen. That's super important. Thanks for bearing with me all the way here. I hope I did justice to Tom's presentation. As I said, I'd appreciate a follow on Twitter if you can. It's a new account, so that would be really cool. Also check out Tom and obviously his social accounts as well, and definitely check out Lightrun, which I think you guys will like a lot. It's a really cool company with an amazing product that you can just try right now, and I'm sure you will love it. If you have questions, my email again is listed here, and I'll be really happy to help. Thanks again for watching.
It was a really cool talk. I already have even a question about that because you talked a little bit about it already with the linters and things like that. So there are a lot of code analyzing tools and tools providing support regarding some kind of bugs, not all of them, but some kind of bugs. When you are now an on-call developer or a person responsible for, or a part of the team responsible for the on-call, where would you see more benefit actually in in trying to implement more linters, code analyzing tools to grab those low-hanging fruits during the development process? Or would you rather take a look at improving the logging and things like that, that you have a deeper knowledge about the running application? Sorry.
Well, it very much depends on your specific project, because if you don't have any linter or any logs, then you've got a problem. So you need both. If you invested only in logs and don't have a linter, then, well, yeah. So it's kind of difficult to say which one's more important, because you definitely need both, and you probably need quite a few additional things like APMs. You can't really live without them because you wouldn't even know about a problem. So one of the things that I'm doing right now is working with the guys at Elastic, where we're trying to explain to people how, say, you look at your APM dashboard and suddenly you see a situation where a server is spiking. Now, what do? Now, normally you just restart the server and move on with your day. That's what I do usually. But that's a pretty horrible thing to do, because there's a bug there. And constantly restarting a server, or even if you have lots of servers and just one of them that you're restarting, it's an indicator of something that will come back and bite you over the weekend at 2 a.m., which is literally what happens to me constantly. That's exactly the time when issues pop up. Especially when I take a weekend. That's the special case there. And for those cases, you need to find the problems that most of us, loggers, linters, most of us do that. Dashboards, it reduces in terms of the tools people use. And when you see a peak in a particular server or anomaly, when you look and you see the line of processing going in a straight line, and suddenly this sort of peak oddly, and you can't explain it, then you need to take a step back and try to come up with an explanation. Now, because you're during office hours, you can sit down and deliberate with your peers and try to understand it, but sometimes it's really, really hard. And then you need deep observability tools. In those cases, usually you can instrument and you can use loggers and things like that to sometimes pinpoint things. Sometimes you need even deeper tools like we offer at Lightrun. But overall, you need all the guns all the time. And any new tool that comes out, usually, I don't necessarily instrument your servers with every single thing that comes out there, obviously, but usually most categories for both APMs, logs, and linters and things like that, there's a reason we have those things. And I notice a lot of developers just don't use any of those tools. I come to companies where they don't even have a linter in their commit chain. So it isn't guarded. There's no guarding in terms of anything other than peer review. So peer review is subjective, and if you happen to have a peer that's more strict, then something doesn't go in. If you have a reviewer that's more lax, then bring it on. Personally, I'm one of the lax guys. I'm just, it doesn't violate anything, go right in. And maybe it's old age or something like that. I tend to trust the developers more. But I'm also to blame for some of the things that sometimes go wrong. So I'm for automating as much as you can in terms of these tools. So I love linters. Loggers are really difficult in the sense that in runtime, you actually pay a penalty for them. Not so much in performance. There is that cost, obviously, and it's noticeable. And obviously, there's the volume of the logs in terms of hosting them and the costs if you pipe them through Elastic or tools like that. But sifting through them, even with search and with all the tools and the filters and everything, once you start logging everything, it's impossible. I know we sometimes overlog, and I find it's actually more detrimental to my job as when I'm on call, where we overlog in some situations. It's very much a matter of trade-off. In the example there, by the way, which Tom originally authored, I used it pretty much as is. there's overlogging there, and still the problem doesn't show. Just print out, okay, we entered this method, we exited that method. And lots of times you'd get that from simple AP logging, which would just log the entry points and things like that, where in a Spring application like the one we saw there. So I think logging should be more refined to very specific points, but the problem is it's very subjective to a developer.
Yeah, we have this issue also because everybody is logging an exception. It must be an error. That's a common use case in our company, for example. Okay. Another question from my side: How big do you see the influence or the potential for AI in this log analysis, etc.? Because I think there's a great potential in automatically detecting anomalies a little bit earlier for reaction, etc., and maybe also generating more detailed reports to reduce the mental load for the on-call developer.
That's a great question. It's actually a big direction lots of companies in this field, including we're taking, because there's so many things. We call it AI, but it's just even simple rule-based systems, which is classical AI from my childhood, can produce amazing insights into very common bugs, because most of the stuff we solve, you can go through a very manual, simple process and find the issue. And also you can see patterns that more modern pattern detection AIs can detect. It's also very easy to make correlations between your repository, because pretty much everything's Git and it's pretty standard by now, your repository and a specific bug or exception that starts suddenly occurring in a production system or in a staging system, same difference. So I think there will be a lot of progress there, but obviously I think it will catch the low-hanging fruit. Like tests, one of the problems is when you run into a problem in production, and those are the problems, the big problems. These are the things that went through our QA process, they went through our tests, and they'll probably go through an AI system, sort of like a hot knife through butter. So I think an AI system will be great to solving simple problems and will be great for pinpointing things. So when we look at code, we look at exceptions, it will give us the general area, which is helpful when your system is very big. If you've got a multi-repo system where you have lots of repositories, especially in a microservice environment where you have lots of different microservices and lots of different things going in all the time, and suddenly you get a failure, finding which repository is even connected to a specific failure is sometimes really difficult, especially when the failure isn't in the specific service you're looking for, because you see an exception in one microservice and the cause is actually because a different microservice changed and sort of created a cascading effect. So it might not be noticeable by a human being, but an AI which looks at all the repositories at once and sees all the commits at once and sees a correlation, okay, this is one of the commits that went between working code and failing code, is more likely to highlight that for you because it isn't too smart, actually. So I think it's a great additional tool. These will be great additional tools when we actually start seeing them being more commonly used in the real world. So I'm very much looking forward to it.